Hi, good afternoon. My name is Emma Chalmers and welcome to today's webinar hosted by John McGuire, Managing Director of Pulsion Technology. We're also delighted to welcome Brian Hill, CEO of the Data Lab, as our guest speaker and industry expert. And thanks to you for joining us today. We've got a packed agenda to cover over the next 40 minutes as we discuss how to avoid project failure. At the end of our webinar, we'll have an opportunity for questions, so please feel free to pop a question into the question box as we go, or wait until the end and I'll pose your question to our panellists. As a quick note, we'll be in touch post-webinar to get your feedback on the session and discuss next steps and how Pulsion can best help support your organisation. And now I'd like to pass over to John McGuire to kick off today's session.
Hi, thanks Emma. So as Emma says, my name is John McGuire, basically Managing Director of a company called Pulsion Technology. We do web applications, we do digital transformation, etc. And certainly a subject close to my heart is delivering projects successfully and also try to avoid project failure. The idea for the webinar came up speaking to a few people actually within the industry and actually sharing notes on just some of the things that happen within projects. So I'm hoping you'll find this quite interesting. Certainly I did a lot of research for it, and there's quite a lot of statistics in here which are quite eye-opening. So let me first of all tell you a bit about my sorry, I think I was muted there. 37 years from doing a computer science degree, industry experience in lots of different industries. Excuse me here. Hundreds of projects that I've been involved in, hundreds of developers I've actually worked with over the years. I've been involved in embedded, desktop, client server, mobile, cloud, and machine learning projects. All for small to multi-million pound projects as well. And I have got experience of success. I've successfully delivered projects. I've been involved in projects that have failed, and I've been involved in overruns. I think anybody within the industry who has the amount of experience that I have, it tells you they haven't been is probably been forgetful about their past. So these are some of the large companies that I've worked for. I've been involved in projects for. I've also been involved in projects via our company for probably hundreds of other companies, big and small. So in terms of researching project failure, this is a quote from Gartner, which I thought was just a great quote to start with. By any definition, the failure rate of IT projects is appalling. I concur with that. It really is. You only have to look at the press to see the huge rate of failures that meet meet papers throughout the past 50 years of people delivering IT projects. Huge failures. PwC did a study, and they studied 10,640 projects apparently. And they found that only 2.5% of companies that they studied as part of looking at those projects completed 100% of their projects on time, which is a shockingly low number of companies actually completing projects on time. Also, the Harvard Business Review, 2011 report, actually stated that a study they did, the average budget overrun for an IT project was somewhat 27%, and 1 in 6 projects overran by 200+%. I've certainly seen projects run by more than 200+% in my experience in the past. A lot of those projects are documented as well in the public domain. So average budget overrun of 27%. Some others put it at 33%. I've read quite a few, but if you actually think about it, that probably means that 1 in 4 people working on projects are working on tasks that were probably never planned, that were part of an overrun. So quite shocking figures. But of course, one of the problems with, I suppose, any industry and just human beings in general is that, you know, success has many fathers, as the old phrase says, failure is an orphan. So nobody really likes to talk about their failures. They don't, it's not something that people brag about. You know, I always think it would be great to see a really, really honest job application where, for example, you know, this would be a project manager applying for a job saying, at my previous company, I was responsible for ensuring project delivery on time and to budget. I delivered 2 budgets on time and to budget. 3 projects overran budget by an average of 33%, and 1 project completely failed. I feel I'd be a great asset to the company. Obviously, it's just a little joke in the middle there, but realistically, that is probably round about what an average project manager would look like in terms of experience. Of course, nobody talks about it, or very few people here. It's unlikely a job interview that somebody's going to say, yeah, 3 of my projects overran. So I think as an industry, within digital transformation, software development, we have to talk more about failures, because it's only through failures that we learn. So, you know, everybody has anecdotal evidence. You do read the newspapers. Unfortunately, most of the failures that you see in newspapers, unless it's industry newspapers, are public sector, and that's generally because there's a public interest as taxpayers. But you really have to look at research into project failures, and especially if you're undertaking, you know, digital transformation projects or software development projects, then you want to go in forearmed, so that you know what you're getting into, you know the dangers involved, so you can kind of mitigate those risks. So starting to look at how common is project failure. So Boston Consulting Group did a report which said something like digital transformation, 70% of digital transformation projects fail. For me, that was a shocking figure. And of course, the definition of failure might be different from company to company. So failure might be that you didn't achieve all your goals. Failure might be, as I have definitely seen in the past, because I've done some consultancy on some big projects, the failure may be that you actually have to never deploy the project that you plan to deploy, and you just have to write off the money you spent on it. So I've seen a lot of different levels of failure, but I don't know what Boston Consulting Group class of failure here, but I would say failure to reach objectives, whatever that may be. They said 70% of digital transformation projects fail. Interestingly, there's another McKinsey report that says only 30% of digital transformation projects succeed. So for me, it's a small sample, but these are big consulting companies who have published studies. That says to me there's 2 data points there. That says to me that there's a high likelihood that actually 70% of digital transformation projects do fail. That the Boston Consulting Group was not a one-off report that looked at the wrong projects, because McKinsey have said that 30% of digital transformation projects succeed. So kind of looks like that might be the level of figure in terms of failures within digital transformation. Of course, to understand that, I suppose we have to look at how projects are developed, and that has some sort of bearing on success and failure as well. So for any kind of non-technical people, maybe aren't familiar with some of the software methodologies, kind of 2 main approaches to software development. One is the more traditional way that software used to be developed, waterfall methodology. The idea is it's kind of like industries like construction engineering, you know, civil engineering, electrical engineering, etc., where mechanical engineering, where people define the requirements of what they want, then they go through a phase of doing design, then they implement the design, actually build the product, they verify that the product works correctly, testing, etc., and then they go into some sort of maintenance phase. So this is how, because a lot of software engineers were computer science I suppose back in the day was not actually a kind of formal subject taught. A lot of people came into software development and computer science from other engineering disciplines and basically learned to code and started to develop systems. So Waterfall was a kind of obvious first choice. But it was found that there were problems with this in terms of requirements would perhaps be not properly captured. Therefore, the design was wrong, the implementation was wrong. You were testing against the wrong requirements, and eventually the customer would see something, but it would be the wrong product, and it would be a huge cycle of going round and round this big stack of work again and again to get things right. And indeed, one of the big problems was that the client wasn't seeing things on an iterative basis. So some experienced, and I will emphasize experienced software engineers would often said, we have to do this in a different way. So they proposed something called the Agile Manifesto, and a whole industry was kind of born with a new way of doing things. This was the new promised land for software development. The idea with Agile is that you do a kind of a discovery phase, and rather than going through this big stack of requirements, design, implementation, you do discovery, you then move into iterative development where you're working quite closely with the client and actually beginning to show them things, rather than waterfall where the product kind of falls out at the bottom of the waterfall and the stakeholder who's commissioned the project decides whether that is right or wrong. So Agile has now pretty much become the dominant software engineering methodology. Of course, you say, well, we had problems with Waterfall, we had problems delivering with Waterfall, so you think Agile would fix those problems. And indeed, somebody's done a study on this, which is a company called the Standish Group, who produced something called the Chaos Report. So this is figures from 2020. So project successful rate, we've reached the heady figures of 42% of successful projects delivered by Agile. So toss a coin and decide whether your project is 50-50 almost, in fact worse than 50-50, as to whether your project's going to be successful or not, even using the best methodology. So they basically said 42% of Agile projects were successful, 47% were challenged. I'm assuming the challenge could be overruns, over budget, over time by varying amounts, and 11% failed in Agile. In Waterfall, that was 13%, and people still use Agile. 13% and challenge 59%, 28% failed. So showing a better success with Agile. Of course, you have to compare like with like, and one of the things about Agile is you can kind of take a project and you can decide that you perhaps can de-scope things to get things delivered on time. So with Agile, you are allowed to change scope. If you go and Google how to deliver Agile projects to a fixed price, for example, then you'll see Agile advocates who say, yes, you can deliver an Agile project to a fixed price, but you just have to de-scope things if the project starts running over. So Waterfall is a lot more stringent in terms of, if you don't meet all the requirements, well, you've probably failed. With Agile, because you're kind of not defining in perhaps as much detail all the requirements up front, and because you have this ability to be agile and de-scope things or change things, then it's sometimes quite difficult to perhaps judge what is a successful project. Is a successful project in Agile delivery, or is it delivery of all features? So I just put that caveat next to those success rates. By any measure though, less than half of software projects are successful, even using our best methodology, which makes you think we probably don't have the best software development methodology that we could, even in 2023. And indeed, this is another report by, I think this is 6.6 group, an internet report, basically saying Agile in the UK is facing a hidden crisis. 1 in 8 Agile projects, which correlates with the previous slide I showed you. I think it's about 11%. In that slide, it's 12% here. But they're basically saying that 1 in 8 Agile projects are failing completely, which do not deliver as well, which is quite a poor failure rate. If you add on the challenged ones that we saw in the previous slide, then it gets to over 50% of projects have some sort of problem, even although they're using Agile. So we definitely have a problem within the industry, and hopefully by taking some of that research, and I've convinced you that we could certainly, I think if this was a report card, certainly I'd be saying could do better. So we've been involved in lots and lots of projects, and one of the big things about being involved with lots and lots of projects is you do see some of the problems that occur. We do project recovery sometimes for people, so the clients who have outsourced a project, for example, before it's not gone well, and either they want a second attempt with that project or they want to try and fix the project. So we sometimes get to see perhaps a lot more instances of failure than some people would see in a typical organisation, just because of the amount of projects we run through. So I've listed a few problems that certainly I've seen as common problems here. The first problem is the use, or I would say abuse, of Agile methodology. What you're seeing is people skip or scrimp on the application discovery, that phase to the left-hand side there, where you define exactly what the system has to do. What people then do is effectively they write down a few user stories, these things called user stories that describe how the system will work. They then think, we know enough now, let's just go and develop. And they go around cycles of these things called sprints to basically split the implementation into a number of sprints and deliver functionality one sprint at a time. The problem with this is that you do end up, if you do not define the requirements properly, and I'll speak about this later, then you're in serious trouble of there being a mismatch between what you're delivering and what you should have been delivering, what the customer thinks you're delivering, because nobody's actually written it down in enough detail. So the abuse of Agile I see is a big problem within the industry. I'm not saying that Agile is not a methodology that could be used. I just see people not putting enough thought into the upfront part of it. Running sprints, etc., seems to be quite fine for most people, but actually knowing what everybody's building, which is a basic requirement, it seems to be something that is a very common thing to happen in Agile. You also look at the industry. We're in digital transformation and software development, growing hugely, huge growth. Stack Overflow is a website for developers online, and the website does a survey every year. It asks lots of questions. One of those questions is developer experience. So it asks of the people who are on the site, and trust me that Stack Overflow is one of the big sites for developers. They ask experience. So if you actually look at the experience there, you can see that 31% of developers have only 1 to 4 years experience. Some of them may not even have been at university. They may have done some of the conversion courses that you can get. There are some 16-week courses you can do to go from knowing nothing about the software development, digital transformation, to basically getting a job within that industry. So you do see a lot of people who are fairly inexperienced within the industry. In fact, if you look at it, 63% of developers have less than 10 years experience. I would also argue that a lot of those developers will have been promoted to be senior developers and project managers. So their experience within those new roles is probably far less than 10 years experience. So there's a ton of people within the industry with just not a lot of experience, and that tells within the industry. If you also look at, compare that with other professions like medical doctors, 22% of doctors have less than 10 years experience. So you can see the difference. Obviously, medicine is a more mature, and probably a discipline that's not growing quite as fast as development, software, digital technologies. But you can see the difference there, and you can imagine the difference that makes to the success of projects. So pretty inexperienced industry in terms of the people working in it, with a methodology. If you look at Agile, with a methodology which is a fairly loose methodology, fairly loose processes. So what could possibly go wrong? You know, inexperienced people with no guidance. And if you actually begin to move on further from that and actually say, well, if people are using Agile and people are inexperienced, then where is it going wrong? And I gave you a figure of 70% of digital transformation projects failed. If you look at a particular bugbear of mine, poor requirements capture, you're seeing that of the 70% of projects that failed, 70% of those failed due to poor requirements. You'll also see up to 50% of project rework is attributable to problems with requirements. And this is a paper by Infotech Research Group. Yet again, this resonates with my experience. So if you multiply 70%, if you take that top figure there, 70% of projects fail, and 70% of those failures are due to poor requirements. If you take 70% of 70%, you get something like 49–50% of projects fail due to requirements. So half of projects, they fail because of requirements, or because of a lack of requirements. I've also seen in Agile projects, when they say up to 50% of project rework is attributable to problems with requirements, what you sometimes see, or maybe more than sometimes see, in Agile projects, you see the fact that people will scrimp on requirements. They will go into sprints. They will start to implement things. They'll show the users. The user will say, "Not quite like that. I wish. Could you change this? Could you change that?" They'll then realise that they've made some assumptions. They haven't gathered the requirements properly, and they'll go into a loop of rework, and they just rework things. That can affect, obviously, project budgets. It's far better to do the right thing right first time, as well. So poor requirements capture is probably, for me, the number one. The abuse of Agile is great, but that's it's a great excuse for not delivering projects. But the abuse of Agile is really relative to people not concentrating on requirements, because it is Agile. It's an Agile methodology. And I would say, in my view, certainly my experience, everything does depend on requirements. So if you actually look at success of project, what is success? Well, success is building the right thing for the customer at the price and the budget that you said you would, and the timescale. In requirements, if you get the requirements right, then you can get good prototypes to show. So generally, you may do a requirements capture phase, discovery phase, whatever you want to call it, and then you might produce some prototype, user interface for the client, just show them what things will look like. Things get signed off, and then you can produce estimates, and then with those estimates you can produce a budget, and then you can produce timescales, and then you can implement. If you have poor requirements, then you probably get incorrect prototypes. Maybe you don't even do the prototypes because, hey, we'll just build the system, which some people would do. You also then get incorrect estimates and an inaccurate budget. So because the requirements have been wrong, the budget and the timescales are kind of made up. People are making assumptions. Nobody to that extent really really knows. People are guessing because the requirements are not detailed enough, and that just leads to a challenged implementation when you eventually do it. This all seems, I mean, if I do believe if I've shown this to civil engineers or to mechanical engineers, this would be immensely obvious to them, and indeed it should be obvious. It's not as obvious in software development, because what we're seeing is people not going through and not doing things properly in terms of defining what a system should actually do. So I would say everything depends on requirements. You get the requirements right, you have a good chance of success. You get the requirements wrong, I say you have a very, very low chance of success in terms of delivering all functionality to the correct budget and timescale. And if you actually look within the industry, so if we go back a couple of those slides there, you'll see 70% of projects fail due to poor requirements. And you then say, well, we must be doing something about that. Surely somebody's addressing this. So how do you find out that data? Well, we had a look on Amazon Books, and we spoke to some people who'd recently graduated from university. The story from university is that somebody doing a computer science or software engineering course will spend maybe one set of classes in one of their 4 years at university, so they may attend a total of a handful of lectures on software requirements. We wondered if we could actually have a look. How do you tell how taught software requirements are? And we thought, how many books are there on software requirements? We had a look on Amazon, and we did a search around a number of different keywords. Basically, software programming, lots of books, 60,000 books or whatever there. Python is a programming language. There's 10,000 books on Python and how to code in Python. Java is another programming language. JavaScript, the same. HTML, obviously used to write web pages. So, thousands of books on those. Software testing is a kind of general discipline within software. So software testing would be something that you'd spend, obviously time at the end of a project testing or writing tests, automated tests throughout the project. Even software testing has 5,000 books. Software requirements is something like 1,000 books. Yet it's the biggest problem with software development, according to some of these studies that you see, but the most under-taught. Of course, actually, if you're a young computer science graduate, software engineer, web designer, etc., you're probably way more interested in those software programming, Python, Java, JavaScript books than you are on software requirements, because software requirements is writing documents, writing text, putting things down. It's not actually hands-on coding, so it does tend to not attract software developers to those books, and maybe that's indeed one of the problems. So I would suggest that one of the big problems we've got is we are ignoring software requirements. We're ignoring the education of people to produce good software requirements as well. And this is a kind of well-documented slide here on something called the cone of uncertainty by a computer scientist called Bohm. So the idea here is that this is at the very left-hand side of this graph is a set of estimates, 2 dots. If you look at vertically on 2 dots that sit vertically, you'll see that there's a dot in the very bottom left, and there's a dot on the very top left as well. The idea here is that Bohm says that if you do not define requirements properly, then the estimates will be really wide. You actually see this all the time in things like tenders, especially public sector tenders, where somebody writes a tender, it is really, really vague, and they ask for some prices. And this curve explains why those prices vary so much, because if you think 2 companies going for a tender, then bottom left you will see that dot at the bottom. Somebody reads a tender which is very, very, very vague and takes a very optimistic view of how little work is involved in delivering that, because it's not really accurate. So they make assumptions of the least possible work. Somebody on the top left, another company at that dot in the very top left, decides, actually, this is really vague, so we'd better build in a fair bit of contingency. Perhaps we assume the worst here. Perhaps we double all our estimates to make sure, because we don't really know the detail. And the variability between those two dots on the very left of the slide can be a factor of 16. So if this was a £1 million project that it eventually costs 1 million, then the people who were optimistic could have estimated 250,000, and the people who estimated pessimistically might estimate 4 million. The project will tend towards 1 million as the project goes on, as requirements are refined. But initially, people get a really wide range of costs. And what actually happens, and I've seen it happen on numerous occasions, is people end up picking the cheapest or one of the cheapest costs, and then they find that there's lots of questions come out as they start to refine requirements, and the cost changes dramatically. So they pick the cheapest cost, but it might be 3 or 4 times what they thought they were going to spend on it, and indeed that's a project failure right there. What you'll also find as well, despite getting the requirements right, you might get the requirements right, you have a requirements document as well. The way that most of the methodologies really work in Waterfall and Agile is they'll ask developers for an estimate. So yet again, let me go back to this. You're asking, in some cases, some very inexperienced people for estimation of a task. So how long would it take you to do this? How long would it take you to do this? So estimation is very difficult, and every software developer, trust me, I don't think I've actually met software developers that like giving estimates, because they are very difficult to do, and they never feel incredibly confident in terms of doing that. But it's part of the real world. Estimation is very difficult, but you can rarely undertake a project without a budget. But you see some common issues that occur with estimation. There's one of the problems about estimation very poor is the lack of experience that you see. You see your lack of experience could be that somebody doesn't have a number of years experience, number of failures in their estimates to actually get quite good at them. It might be that they've got lack of experience in a particular technology. So you look at ChatGPT, which is just recently been launched. Nobody has 20 years of experience in doing ChatGPT projects, so it's new to a lot of folks. So it's very difficult to estimate how to use that technology and the best way to actually estimate how long it's going to take to undertake a particular project within that technology. You'll also see estimating at too high a level where people just don't have enough detail, and they don't recognise that they don't have detail, so they'll do a kind of finger in the air estimate. It's like, I could implement that feature in 5 days or 10 days or 20 days, whatever it is, and they don't question the requirements. They just take a feature and make up a number that they think in their head they're not bad people. They're just they just might be a bit over enthusiastic about an estimate, and they think they can do something, and only when they get into it do they start opening up the problem and start to realise that they haven't thought about it in enough detail. We've seen evidence of developers forgetting tasks. It's like, oh, I finished the task, but I forgot about this, so I didn't estimate that. So you see these things going on as well, which we tend to get round with processes and kind of talk about at the end of our presentation on that. Not estimating in detail, people don't do detailed enough estimates. You know, they may estimate in 5 days, 5-day chunks, which might sound fine to a non-software developer, but in 5-day chunks, they're perhaps too big. A lot can go wrong in 5 days, and it's quite difficult. We prefer people to be estimating in very, very small detail if they can, almost visualizing the task and exactly what they're going to do, and I mean exactly what they're going to do for that, so that we can look at it in detail, and hopefully down to the level of, I will complete this in 1 day, I will complete this other task in a day, etc. And of course, humans are notoriously bad estimators as well. Software engineers are notoriously bad estimators. So our advice would generally be to try and capture data and try to look back at that data. This is also advice of, there's a guy called Steve McConnell who wrote a book, I think, called Software Estimation, and he bemoans the fact that humans are very poor at estimation. So you want to build up a database of data of previous estimates so that you can perhaps look back. You will still take human views, absolutely, definitely, but check those views against what's been done before. The example would be that somebody says it's going to take 5 days to implement a feature, for example, but it actually ends up taking them 10 days. And that project comes and goes, and a year later, something very similar to that feature comes up in a new project, and the person just estimates another 5 days for it. If you have the data, you can look back and say, we did something very similar. What was our estimate and what was our actual previously? So capturing data, we definitely recommend, because estimation is a problem. Estimation is very poor. There are, of course, other project factors. These are general kind of project manager type factors that come into play. Technology, in my experience within the industry, is never usually a huge deal. You would think it would be, and certainly there's new technologies, and sometimes people aren't maybe trained enough on them. And I would say that if you're undertaking something in a new technology, either try and find people with experience or make sure the training is undertaken. But I can't actually recall a project in my working career where something has failed because of technology. People work around these things and get them, get stuff done. So there's never a problem with technology. Control scope and creep, obviously standard project management. Monitor progress and adjust, yet again, pretty standard stuff, and always involve stakeholders regularly. So I would say whatever you're doing, you should involve people who are actually, interested in the project. And indeed, there is trying to make sure stakeholders are involved regularly can be a bit of a challenge as well, because sometimes stakeholders don't have time. But these compared to the other things, the abuse of Agile, inexperience within the industry, and software requirements, poor software requirements and estimation, these are minor project factors in my view. So I think I've spoken for enough on that sort of level. I want to see if I can bring in Brian from the Data Lab, who is actually a client of ours. We know him within our software industry. Brian has great experience, so it was really just to see if I can bring in Brian, and perhaps Brian could give us a quick introduction to who he is and what he's done and what he does.
Hi, John. Thank you. Just in terms of introduction, so I'm Brian Hills, Chief Executive of the Data Lab Innovation Centre. We're Scotland's Innovation Centre for Data and AI, with a mission to change lives and improve productivity and societal outcomes by transforming the way we use data. So looking at your graph, John, of length of experience of people in software and tech, I think I'm probably going towards the far side of that one now. I started off with a software engineering degree from, or computer science degree from Aberdeen. Then I moved into telecoms, system, software engineering and testing last century, and then started to develop a career in software and analytics, and moving through being an analyst to leading teams and building data teams, and then at the Data Lab designing our services and products and moving to CEO. So I've had quite a bit of experience on both creating and deploying software systems, and also systems using data and machine learning, and also on the other side of that, as you said, John, procuring systems to enable us to do that at the data lab.
And what have you found, Brian, in terms of, I mean, I've obviously touched on, it's always, I think it's always good to speak to people who have years and years and years of experience of delivering systems, because I sometimes feel it's like anything else in life. The more you've done it, the more you learn, and the more you've seen, and you've been there, done it, and you have made mistakes of your own. You've seen mistakes happen. So it's always, I think it's always as more experienced people, it's always our responsibility to try and kind of pass that on, so that people don't make the same mistakes, and you don't see the same mistakes being made. But anything in particular of the areas I've covered that kind of resonate more or less, or anything else that I've missed there that you might see as problems?
Yeah, probably 3 areas I would think about after reflecting on your discussion. One of them would be, and I always say this about data people, right? Data people like to measure everybody and everything apart from themselves. We're not very good at reflecting on things, and that's what I found in running data teams. And back to your point on measurement, I think we could all benefit from much more of a focus on measurement and retrospectives on how projects have gone, and how we should learn from them and evolve, and how we can forecast better, as you mentioned. So I think increasingly data is a very useful tool that should be used more. And within that, I'm starting to see in industry new project forecasting tools that use a lot of historical data and algorithms on top of that to help project teams in their estimation. So we're seeing some new things coming through to potentially help in that area. I think the second of the 3 points for me would be recognizing that projects are, I think you alluded to this, are dynamic. So at the Data Lab, we're hosted by University of Edinburgh. So if we are working with a supplier to create something, we need to go through a procurement process. I think one of the things I learned from that was that, the procurement process is there for very good reasons, for value for money, to be very clear about requirements, and a whole host of other things. But after you've moved through that process and selected the supplier, day one can be very different. When you actually get into those requirements, the agility required to plan around unexpected things, the agility to plan around, well, some of those unexpected things, let's step back on that, could be, your procurement process may have taken 3 to 6 months, and then the shape of your team internally may have changed during that point of view, but at that point of time. So, you've got responsibility as someone commissioning this to make sure you're set up correctly to enable the project to succeed. And over longer term, that can be a bit of a challenge. But also, I guess, generally in the digital world, most of us have digital systems of some sort. We might have a CRM system already, a finance system, or whatever it is. We've all probably got a range of systems. And one of the challenges I see is that when you procure a new piece of work, is how do you clearly define the interfaces between them? Because you need to work with the suppliers of those other systems to get clear pictures as well. And I think that's something that we found interesting in this landscape, trying to work through. So there's the measurement piece, there's the being dynamic around the projects, and I think one of the new pieces for me specifically in data and AI, John, would be a lot of data and AI projects were what I'd say cottage industry. So we'd get an export of data, would apply some statistical analysis to it or other types of analysis, and algorithms, and we come out with a deck and we present that to a customer, and much more now these things are end-to-end pipelines and engineered systems. And one of the key things that we're seeing that organizations need to lean into is the consideration of ethical design of these systems and the implications of what can come out of them, and the transparency and explainability of these systems. And for me, over the last, I guess, 5 years, that's come much more to the fore. And so thinking about how you do that when you get to requirement stage, I think is really important. And I don't think that many organizations procuring these types of systems at the moment have the experience to hand to be able to do that as effectively as they could. So there's three initial thoughts.
Yeah. I mean, I think Brian it was interesting you speak about ethical and explainability. I mean, you see, certainly we will speak to somebody about a system that made a decision on somebody, but made a decision on somebody using AI, and they had kind of developed something because they got off techies developing a machine learning artificial intelligence model. But after having spent all that, they said, actually, we can't now explain how that decision was made. If anybody on the call, a quick explanation here is that a lot of artificial intelligence models and AI is kind of like a black box with these things called neural networks. You train it to make decisions, but you can't then ask it how it made a decision. When it makes it, you can just say, well, here's all the training data. So certainly, Brian, I've seen kind of people leave the ethical part, because it's quite right. If somebody was, for example, refused a mortgage or insurance or life insurance or whatever, then they kind of have a right to know. But some of these models may be very efficient, but they can't explain. So there are softer things around projects, I suppose, that you do have to take credence of. Otherwise, you get to the end and a business person or a member of the public may scupper your grand idea.
Yep.
Yeah,
absolutely. And we're finding that increasingly the case, John, as more of these systems are deployed. And I think, for me, that there's a gap in education on a couple of levels. Thinking back again to that chart you showed on the new entry level, I think, again, courses in software engineering, data and AI are all very well defined, but they're very packed full of content, and often there's no room to include the discussion of how you think about these things in an ethical way when you're designing and implementing them. And then I think it goes through to the other end of the spectrum when maybe you have a lot more experience in the industry and you're trying to buy these systems or engage with suppliers to do it. Knowing the right questions to ask and the frameworks to use, I think, is something that in general would be a benefit if we could enable more organizations to be able to have access to that knowledge.
Yeah. And I suppose just one other point that you brought up there was almost like dynamic state of projects, and it's something you're seeing within, I'm sure a lot of people have seen it within their own organization, is the changing of the team, whereby people are leaving, especially after COVID, where people decide they want to move on to a different organization, change of life, even retire, and you're seeing teams that are in a constant state of flux. So if you've got a project that lasts a year, 2 years, then it might be that you lose 2-3 people over that period, just because it's the way it works within digital industries. Is that something you find as well, Brian?
Yeah, absolutely. I mean, no team is ever static, John. Lots of different things can happen, and I'm happy to share from personal experience. When we were engaging with yourselves, and I was heavily engaged in requirements and procurement, it doesn't necessarily need to be people moving to other organizations. When I moved to CEO role, suddenly we had a gap in the kind of product role of what we were doing. So, I think we would all recognize the dynamics of the organizations that we work in. They're not things that remain still and stable for 6 months, a year, 18 months, etc. People are always moving roles, moving in, moving out, etc. Different experiences, and I think that's something that that we've learned that it's a good thing to be aware of. And how do you manage that from a risk perspective? And I guess the other element that I'd add to that, and from working with yourselves as well, to be honest, is success in these projects is down to relationships and the ability to collaborate and work together. I think we have to view it as a partnership to develop these things, rather than think of a pure demand supply relationship, because at the end of the day, there needs to be give and take in both directions to help overcome the kind of dynamic nature of the field that we're in.
Yeah. No, I totally agree. And I tend to think as well, when you talk about team change, you talk about, we're talking about ethical things. I tend to think ethical things should be in requirements. There are things called non-functional requirements. You must be able to explain this. If we've got a requirement spec for an artificial intelligence system to decide on mortgages, then one of the soft requirements, one of the non-functional requirements is the system must be able to explain its decisions, for example. And I think you also see the fact that if teams are changing, it's all about documentation as well. There seems to be a move within the industry more away from process and documentation, or not as much, but documentation really does help in so many, right down to having a really, really good, well-documented requirements is what I'd say.
Yeah, absolutely. Now, just expanding on that point, we talk about corporate knowledge and corporate history kind of embedded in the team that that you're working in, and that corporate knowledge, when we manage our risk registers, how do you think about that as people move roles and move on? That's in a state of flux over time. So even if you've done the requirements, you've got the system deployed and you're using it, then over the next 2 years as it's used, people will move in and out and up and down of the organization, and you need some consistent place where you can understand the record of what's happened, how to use it, how to engage, etc. Where I think that, as you mentioned, the documentation and having that written down is really key.
Yeah. No, well, thank you very much, Brian, for that. I'm aware of our time, so I'll move on from there. But thank you very much. I appreciate it. Hopefully, those on the webinar do as well. So, in terms of for us, in terms of requirements, we as an organisation, we realised we had the requirements journey to make one of our biggest problems was requirements and estimation. So for us, we went through effectively a internal analysis and realised that requirements and estimation were the biggest problem that we could see in projects. So we decided to improve it ourselves, and because we had less experienced staff in some cases, not well experienced in requirements, they were not capturing all requirements accurately, and they were forgetting requirements altogether, and thus we were getting estimates wrong. So for us, when we talk there about process, and Brian talking about process, we went off and we moved away from things like Microsoft Word and Jira, etc. But didn't move away. We decided to supplement them with something else. So we developed our own application to structure requirement questions to ensure consistent capturing of requirements, and we then took that tool, modified it to produce wireframes automatically. So we were building up a process whereby we took out the lack of experience, we made the caption of requirements more structured, and we actually use that tool to generate tasks and estimates. We actually we can set up those estimates within the tool, but we've actually I think for us, we've identified a lot of these problems through the research that we've done and through our own experience, and we've tried to build tools for ourselves that can actually take away some of those human elements, some of the lack of requirements, for example. We've tried to guide people through requirements and make sure they get them as accurate as we can. And Brian was talking about that corporate knowledge there. What we can do is we can then feed back that corporate knowledge into the tool, into the process, so that next time we do another set of requirements, the questions that were perhaps not fleshed out enough and for the first project are now done in a better way. So that's really it. In terms of lessons learned, poor requirements will likely lead to unsuccessful projects. Absolutely, definitely. Agile methodology should not mean no upfront requirements. I don't know if I can emphasize that enough. Adding more process or automation to requirements capture definitely can improve the consistency of requirements and improve your project. get as experienced a team as you can. It's easier said than done in an industry that's growing so quickly, but you be aware of the level of experience of your team, and poor requirements can lead to bad estimates. And that's one of the reasons I think that we have a high rate of project failures. It's poor requirements leading to bad estimates, bad budgets, and when you don't deliver to a budget and a timescale, that can be seen as a failure. And I think that's us. I think I'll hand back over to Emma. Emma, hopefully I didn't overrun too much. Back to any questions that you have for myself and Brian.
Great, thanks very much, John and Brian, for taking us through today's session. Hope you've all found the webinar valuable. We'll now start a Q&A. We've had a few questions already, but please pop yours into the question box. The first one is, you said that there's a problem in the industry with delivering software development projects and that the problem is a lack of detailed requirements. What's your approach to assuring requirements are accurate?
Let me take myself off mute. Yeah, our approach is to try and automate as much as we can. People talk about digital transformation, and what we've done, what we try to do internally is digitally transform ourselves as well. You find a problem, you find a problem with humans effectively. You know, it's hard to get. It's hard as humans to remember everything in requirements. Requirements are incredibly complex. So what we've tried to do is automate that process by having a tool that can allow us and prompt us to capture the right requirements, and then I think I was saying at the end there, maybe a bit rush through, but to then produce a requirements document off the back of that and produce things like wireframes off the back of it. So what we've tried to do is we've tried to make requirements more agile within our organisation, so that we can play with requirements more, we can get things right for our clients more.
Great, thank you. Next one, how do you define requirements and therefore cost estimates in a tender process?
Yeah, those become, I mean, in terms of tenders, I don't know whether Brian might have a view on this as well. Probably will, not to put words in Brian's mouth, but yeah, in terms of it's very difficult with tenders. It's very difficult because it takes a lot of effort to actually get the requirements right at times. The problem with tenders, if you don't get the requirements right, you will get the wrong estimates. It was that cone of uncertainty where you get a high level and a low level because the requirements are not yet really well defined. And people often ask us why, I've got some quotes for software, why are they so different? And they're so different because the requirements are not well defined. And if you want to look at requirements which are not well defined, I would refer you to some of the public tenders. I don't want, you see public tenders more often than commercial tenders because public sector must have value for money and they must be accountable. But it's also a very difficult process to go through and get right. And sometimes you don't really know what you're building. I've always thought that tenders, for example, should be a two-stage process. You should tender for getting requirements or getting discovery done, and then you should tender for the actual system based on something which is quite detailed. I don't know if you'd have anything to add with your experience, Brian.
Yeah, I think maybe two things to suggest here, John. On the tendering piece, from our experience and what we've done in the past, we've engaged a number of suppliers to have discussions before we release the tender in the first place to get some broad input on approaches, areas that we need to think through, etc. So we're actually taking some input to help shape the tender in the first place, to sanity check what we're proposing to do and the broad kind of outline skeleton structure and pricing, etc. So that's been a helpful input. I appreciate some organisations are unable to do that depending on the rules that they operate within. I think the other important thing that I found in the past as well is having when you're tendering a technical competency within your own organisation who can provide the interface into suppliers as well, and who knows the questions to ask and can open the discussion up. And I think part of that sometimes is you may have that technical person in your team, or you may have to grow your kind of intelligence as a customer in knowing how to engage with the supplier network to be able to do that in a productive way.
Brilliant. Thank you so much, both of you, for your time. That concludes our webinar. Thanks again to both of you and to everyone who attended. If you've not already, take a minute to join the Pulsion Technology Lifetime community. Keep up to date with all the latest news and future events. And as mentioned at the start, in the next few days, we'll reach out to get feedback on the session and discuss available next steps. Thanks again, and have a great day, everyone.